Chapter 2, Exercise 36. Verify that for all sets, the following are correct. Chapter 2, Exercise 36. Verify that for all sets, the following are correct. A minus A intersect B is equal to A minus B, and B, A minus B is equal to A intersect B. Right, so let's get started. For this first one, we're going to use De Morgan's laws to push in this negation. So this set is equal to A minus A union A minus B by De Morgan's laws, which is equal to the empty set union A minus B, which is just equal to A minus B. And there you have it. That's the first assertion done. And now we have to show that A minus B is equal to A intersect B. Okay, for this one, I couldn't find any fancy tricks to do, like De Morgan's laws. Feel free to comment if you see it, but let's just do a regular proof of set equality. So first we're going to show that A minus B is a subset of A intersect B. Right, so let's suppose, as usual, that X is in A minus B. Okay, then X is in A and X is not in A minus B. And this is equal to saying that X is in A and it is not the case that X is in A minus B, which is the same as saying that X is in A and it is not the case that X is in A and X is not in B, which by De Morgan's laws, not for sets, but for logical formulas, this is equivalent to X is in A and it is not the case that X is in A, or it is not the case that X is not in B. Right? Okay. Now, if X is in A, then let me just wrap these up here in braces. Then not X in A is false. So it must be true that not X is not in B is true for this formula. I just realized I could have simplified this one step further to be true. Essentially, it's just a case analysis, proof by cases, if you will. That's what it's usually called. You have that X is in A, and then you have two possibilities for this formula on the right side of the and to be true. Either X is not in A, or it is not the case that X is not in B, which I should have simplified, honestly, to X is in B, right? And this is the direct opposite of this, so we can cross this one out. Hence, this one must be true. That is what I was trying to say. Okay, so not X not in B, which is equivalent to saying that X is in B, must be true. Thus, X is in A and X is in B, so X is in A intersect B. Oh, I need to add an extra page. So A minus B is a subset of A intersect B. Cool. And now for the second part, we have to show that this works when you flip the containment. Right. So let's suppose that x is in A intersect B. Then x is in A and x is in B. So, or rather, since x is in B, x is not in A minus B. So, x is in A and x is not in A minus B. So, x has to be in the difference of these two sets. And thus, A intersect B is a subset of A minus B. And we conclude that these two sets are equal. And there you have it. That is exercise 36 of Enderton's Elements of Set Theory. I hope this was helpful, and I will see you in the next video. Bye-bye.